This conference will now be recorded.
Hello, everybody. Jordan Girth here from the National Weather Service Office of Observations. Thank you for joining us for the Satellite Book Club Seminar Series. This is session number 43. Hope everybody's staying well and happy April. Today's presentation is limitations of the GOES-R series of satellites for monitoring wildfires and methods for their mitigation. The presenter, Chad Gravelle, Acting Chief of the Science and Training Branch and Techniques Development Meteorologist for the Technology and Fusion Branch at National Weather Service Southern Region Headquarters. The facilitator is Bill Lai, meteorologist with the Regional and Mesoscale Meteorology Branch at NWS STAR. Just a few reminders before we get started that this session is being recorded and there will be an opportunity for Q&A after the presentation. Please post your questions in the chat and we will field them in the order they were asked. We are looking for future presenters, so if you have an application you'd like to share with the field, please feel free to get in touch with us. We'd love to have you in a future satellite book club. Now coming up on nearly 1 year of weekly presentations. So really appreciate all of our presenters and all of you for tuning in. The training team can help create training materials that may be unavailable. Brian Mott, the Office of the Chief Learning Officer, can answer your questions regarding that. I'd just like to thank our Tower S team, particularly Kashad Bowman, the Office of the Chief Learning Officer, and GOES-R and JPSS program. There's a lot of behind the scenes work that goes into the Satellite Book Club. Really appreciate them setting it up and letting it get started every Thursday. Without further ado, I'd like to introduce Chad, hopefully not a stranger to you and not a stranger to the Satellite Book Club, with another repeat presentation. As I mentioned, he is the Techniques Development Meteorologist at the National Weather Service Southern Region Headquarters in Fort Worth. He develops, implements, and manages advanced techniques for preparing forecasts and warnings, with an emphasis on applying new data sets and technology to improve forecasts that drive decision support services. Dr. Gravelle also initiates, plans, coordinates, and oversees the transfer of emerging technologies from the research community to the operational warning environment. Previously, he was the GOES-R Satellite Liaison at the NWS Operations Proving Ground in Kansas City. Chad, welcome back.
All right, thanks, Jordan. I appreciate it. So, you're probably interested because, everybody loves, the GOES-R series of satellites, GOES-16, 17 for fire detection. But I'm going to just talk about a couple limitations today. And maybe we can brainstorm potentially on how we can resolve some of these issues, with those of us that are in attendance. And I guess I should let me go back by saying that all the imagery in here has been borrowed. Well, let's just tell it how it is. I stole it all, right? But it's from Bill Lai, who's our co-host today, and then the Scotts from the SIM satellite blog, which most of you are very familiar with. All right. So when it comes to detecting and monitoring wildfire threats, GOES-16, 17 is basically, it's like the best thing since sliced bread, right? Like we really know this, and this is 1 minute imagery, and I know it's not going to come across well in the go-to meeting, but you can see overshoot, or you can see pyrocumulus, you can see rapid fire growth. Having this imagery every minute is really great for wildfire monitoring and detection, and we know that, and it's probably one of, if not the best improvement going from legacy 13, 14, 15 GOES to the GOES-R series of satellites. But it's not all rainbows, butterflies, and unicorns, and that is why we're having this conversation today. So let's talk about these limitations. So the first limitation is the parallax. And some of you might be surprised by this, because when we talk about parallax, especially with operational forecasters, it's usually due to the cloud tops of deep convection, right? As you get poleward, the deeper the convection, the more displaced poleward that signal will be compared to in reality, okay? But it happens with fires as well. And it happens with in higher terrain. So what we're looking at right here is the East Troublesome Fire from October 22nd. And so here county lines are here, but you can really kind of say that this boundary that I'm kind of going up north and south, at least this part of it is basically at the Continental Divide. But you see we had a very large wildfire going on here. But because we're at 10,000, almost 11,000 feet in this area, when you compare it to VIIRS imagery, which is more of a direct overhead look at that fire, look at how far south. This is like, so here was the head fire at this asterisk from GOES. I'll go back. You can, we'll put it right around there. And then you can see where the head fire was in reality in when you look at VIIRS imagery. And this is like maybe, I think it was like, when I figured out, it was like a 5.5 kilometer difference. So a 5.5 kilometer shift, which may not seem like a big deal, but when you're really trying to provide IDSS, or if an IMET is trying to provide support and they really want to know where that fire is, it's a big deal. So I just want everybody to be conscious of this. And here's a nice little illustration of this. And when Bill put this together, he was really looking at surface features, but fires are surface features, right? It's on the ground. So when you take a look at the at where the satellite is, at the satellite viewing angle, you know, any kind of elevated surface feature directly under the satellite on the equator is going to be in the right spot, right? Any kind of surface feature, if you're looking at view A, that's at the surface at sea level, right, is going to be exactly where it is. But you can see by looking at view C here, that's where this parallax comes into play, right? So when we're in high terrain, like in my example, we're at 10,000 feet, you see a lake or a fire that's on the ground, that's going to be slightly displaced poleward in reality. So that's where the satellite, at least the GOES perspective, will sense that. And you can see from the previous two examples, it's pretty good. Here, so kind of going back to this East Troublesome Fire, this is the 3.9 imagery from GOES-16, and this is when about the time where the fire was moving across the Continental Divide, and that's a big deal. Number one, this really just doesn't happen very often. There's not very much brush at this. We're above the tree line, basically, right? So there's not a lot for a fire to burn. So that's one reason why this really isn't very common. But it's also a big deal in this area because on the other side of the Continental Divide, you have the Rocky Mountain National Park, you have Estes Park, you have big tourism area. Even in October, leaves changing color, you get the idea. So GOES imagery showed the fire basically here, but in reality, at this exact same time, the fire was more closer to Mount Wu here. So it had already crossed the Continental Divide, even though in this image, while you could probably say it probably did, there might be some uncertainty. If the fire was already located here because of this displacement, we're very confident it had already crossed the Continental Divide and was impacting areas around Mount Wu. So that's limitation number one, okay? Limitation number two is the resolution. Now, we know the resolution is 4 times better from legacy GOES to the GOES-R era. But we're still looking at a 2-kilometer pixel. And you know, I've blown this up for illustrative purposes. But when you compare that to VIIRS imagery, okay, when we're looking at 375 meter resolution, that's 25 times better than 2-kilometer GOES, even though you would only be getting it, you know, a couple times a day potentially. I'll show you why there's a very good application that we can use. And why I say it's 25 times better is you can fit 25 of these pixels, approximately 25 of these pixels, into this GOES-16, 17 pixel, basically. So that's why I say it's 25 times better resolution, okay? And one of the big applications that we can get by using this imagery and then comparing it to GOES at the same time is for mapping, right? Like you can see there's just like a lot of detail at 375 meter resolution of this 3.7 imagery. So shortwave-IR imagery that you can get when, and then you can potentially map this, right? Now this is CHAD mapping, right? I took PowerPoint and I made a really nice map there of the fire using a couple different thresholds, right? But you kind of get the idea. And then if you have that overlaid, even though that VIIRS time has passed, but you had some processing to create the map of one where the fire is and the high resolution of it, just take a look at you know how you can almost have the meteorologists can correct themselves. So the IMET can take this and look at it and then look at 1 minute imagery with that static image overlaid. You know, on these big fires, we get IR planes that fly over these fires and do really high resolution mapping. But that's not always available either. Like sometimes smoke can obscure things. Sometimes the winds are too strong and you can't do these flyover flights. So this could be a really big application of using VIIRS imagery along with GOES imagery. So what did we need yesterday? We really need this VIIRS imagery in AWIPS, not only the 3.75 band, but also the fire temperature RGB. Okay, so these are all, you know, according, you know, this is, you know, Chad's world, right? But I've talked to a lot of, you know, weather service meteorologists and IMETs, and they agree with this. Number three, we need GOES and VIIRS fire perimeter mapping. Okay, and not only the example I showed here from the VIIRS imagery, we also need it for GOES. And Google's doing this, right? But we need it in AWIPS. And that's the thing. So, you know, my challenge is if Google is doing this and they're doing it with GOES-16, 17 imagery, then we should be able to do something similar in AWIPS. And then number fourth, maybe parallax corrected GOES imagery, right? I think there's some possible things that we can look at there. You know, fires on the ground, you wouldn't have to do every pixel. I know that there's been some attempts at doing parallax corrected imagery for visible imagery. It didn't get really great feedback in the hazardous weather testbed because there was artifacts that were being kind of developed and the meteorologist was already kind of good at that. But when you're dealing with surface features, we know every pixel's elevation, we can move those pixels potentially. So maybe there's some promise there. So with that, let's discuss this. I know I didn't have a ton of slides, but hopefully they're thought-provoking and myself and Bill can, you know, can have a good discussion here with everybody.
Thank you, Chad, so much for that very thought-provoking introduction to this topic. I do want to encourage everyone to stay on for the discussion and to complete the feedback survey that will be posted in the chat room shortly. Before we have this discussion, I do want to mention that, boy, are we in for a treat next week. Next week, Thursday, April 8th at noon Eastern, we have Eric Stevens, the Fire Weather Program Manager from the Alaska Interagency Coordination Center. He'll be discussing fire weather in Southern California, and we all know Eric always gives a lively discussion. I also would like to encourage attendees to contact the Tower S team, Lee Byerly and Kashad Bowman, for questions about the Satellite Book Club or for a configuration of satellite products. More information on this will follow in an email from the Tower S team. I do want to remind everyone, please put your questions and comments in the chat. I think you can also raise your hand and speak as well. So while you get your questions in and while I still have the floor, I do want to make a few more comments. With that East Troublesome fire in northern Colorado along near the Continental Divide that Chad talked about, Boulder did do a great job utilizing GOES imagery to determine and alert partners that the fire may have jumped across the Continental Divide into Rocky Mountain National Park. You know, there was a certain degree of confidence in there, but they did this accounting for that surface displacement at the high terrain. So they were aware of a displacement, and in providing their decision support, were accounting for that parallax shift. So while they were successful utilizing the imagery, I imagine that they would have probably been able to make a more confident decision and provide a more confident decision support with imagery that had already been trained corrected, because they're having to do that correction in their mind. So I think this really underlines the importance that with the imagery as is, I think high terrain forecasters really need to be aware of this terrain displacement within their forecast area. And at most, a terrain correction would be great. So having said that, I think Chad talked about maybe the need for a terrain correction of 3.9 micrometer imagery. And this came up in the chat. A similar terrain correction has actually already been applied to VIIRS EDR imagery last July. So if you recall in the past, landmarks at higher elevation in VIIRS imagery, such as city lights and near constant contrast imagery, hot spots, lakes, they would appear to kind of jump around from swath to swath in the VIIRS imagery. These navigation shifts were due to the same thing, the terrain displacement at higher elevations far from the satellite subpoint. So I think this effect appears more dramatic in the VIIRS because a feature's location is changing from swath to swath. With GOES, the displacement's constant for a given feature. So I think for this region, the cell for a terrain displacement with GOES might be a little more difficult from VIIRS because with GOES, it's constant and forecasters can be trained on it. So I think to start, are there any comments, other comments on the terrain displacement? Forecasters from high elevation offices, are you aware of this? Are you accounting for this when you're geolocating surface features such as hotspots? I'm looking through the comments to see if you have any comments on terrain displacement, please speak up. And one comment from Ryan, as a forecaster in California, we need to be careful about sharing imagery on social media and saying where the fires are. Again, because of parallax, that might not be exactly true, but based on the imagery. And it's important to confirm with cameras and eyewitnesses. So Ryan mentions also as an IMET, these differences of 5 kilometers on satellite versus what firefighters and air attack is reporting as an example of the fog of war. These differences are huge for evacuations and other decisions. So yes, yeah, generally, yeah, only a few kilometers, those are huge displacements. All right, I'll bring up some questions. So now getting to, there's some comments about fire perimeter. So especially for IMETs, is AWIPS, Chad mentioned that we need this in AWIPS. Is that where we need it? Are IMETs wanting this type of fire perimeter information in AWIPS, or would it be better to have elsewhere on the web? And on that point, are there already fire perimeter resources on the web? Chad, can you talk to maybe what resources they already have?
Well, I mean, the one that I know of is like Google's been dabbling in this, right? Like especially out west, you know, they have for many fires, and they have this infrastructure already in place. And I watched it last fall and last summer, and I thought I was pretty impressed, honestly. You know, going back to the AWIPS question, and I've asked this recently, and you know, and please, other IMETs that you know, there's quite a few that are on today. Please chime in. But I think they're still their go-to is AWIPS thin client, and then when that ends up being potentially not as responsive, I guess is a good word, then they would probably go to a web resource. But I know that there's investigations into potentially moving or talks about moving that thin client infrastructure to a cloud approach, like a cloud AWIPS approach. What that I use quite a bit, that if you've been on the Satellite Book Club before, others have used. It's very responsive, it's very lightweight. You do it in a Chrome browser or Firefox browser. And I've been super impressed, right? You're only pulling down the imagery that you need or the data that you need. And it's not as much of a resource hog potentially as AWIPS thin client. So I still think that type of this type of information would be good to have in AWIPS, and also early on of a fire, you know, the IMET isn't there immediately. The WFO is providing support for maybe 36, sometimes 48 hours. It takes a little time. You know, the IMETs just don't appear out of thin air. You know, everybody would love that if that was the case. But so the WFO, which would be using strictly AWIPS, would be providing support early on as well.
Yep. And yeah, Chris Schmidt mentioned regarding the Google is doing perimeters, but they're not, to my knowledge, applying parallax and trying to use both satellite, or they are using both satellites when they can. And Mike Pavlonis mentioned that the Google application is simply smoothing of the data.
Yeah, but and that's fine, but it's something, right? Like we're not like, and I guess that's my you know, that's one of my challenges, right? Like we need this in AWIPS, I feel, and so you can overlay these things. You can overlay the 1 minute imagery and see how it's evolving as a first guess perimeter, and you can do some of these things. I think that's what the challenge would, you know, in my opinion, is to the community. Smooth their, and I'm sure Mike's not like, you know, dismissing that at all, but I think that's better than nothing, and maybe we can even do it even more intelligently. We have that expertise.
And Mike does mention that Nestis is developing a strategic plan for the fire product portfolio, and it includes parallax correction, incident-based products, and detection alerts for forecasters. So that's good to hear.
Yeah,
at
that
least
is
in the plans. Interesting comment from Ryan again. When they're on fires, the IMETs, the GIS unit will often have the best intel from aircraft and fire staff literally walking the fire to verify perimeters. So having the fire perimeters in AWIPS would be great for staff in the office. So that's something I'm curious about, and I hope IMETs could chime in. So you have folks walking the perimeters and you have aircraft for at least the large or fast growing fires. So how does satellite play into that? How do perimeters derived from satellite add to that? And while you're thinking of that, Brent mentions fire perimeters would be good both in AWIPS and as a downloadable shape file and KMZ file for WFO use in wildfires in their area. That also makes it available to IMETs, yep, but also downloadable for other applications that IMET use on their computers. So I guess maybe from the satellite perspective, it's just another source of information in addition to the aircraft and folks on the ground. I'd still be interested in, knowing how readily available fire perimeter information is from resources outside of satellite.
Yeah, I would imagine it's once a day, maybe twice a day at best, but maybe I'd love to hear verifying of that, because if we got a shapefile, in AWIPS pretty quick, right? And then you're having the GOES 1 minute imagery overlaid on that, you can see which parts are hotter than others. Hotter means I'm talking more active, right? Not temperature of the fire, but like more active areas of the fire. You can see where that's expanded too, very, very quickly. I think there's a lot of potential to fuse that information together.
And then also, Chad and others, is GOES and VIIRS fire perimeter mapping information preferred over the raw imagery, or would you want to be viewing both? And I mean, maybe for an IMET on the fire, do they just want the perimeter information, or do they want to view the imagery as well?
Yeah, that's a good question. I'd like to hear others, chime in. My guess is they would probably take both, but
Always.
but I'd love to hear some confirmation of my thoughts.
National Weather Service, Regional Operations Center. This is Kurt.
Can you please mute yourself if you're on the phone right now?
Good. How are you?
Mike Pavlonis mentions it would be good to gather requirements for fire perimeters. How useful is a perimeter that is derived from moderate coarse resolution data? So yeah, that's a good comment, and I don't know who would collect that information, but that would be good to know.
Hey, this is Ryan Walburn. Can you hear me?
Yeah, go ahead,
Yeah.
Ryan.
Sure. I guess maybe just to try to throw some out to some of those questions that were posed. I mean, historically we would get, one flight a night in the middle of the night. That aircraft comes out of Boise. But like Chad alluded to, it could be canceled, or there could be so many fires that your fire doesn't get a flight, mechanical issues, smoke, whatever. Lately, at least in California now, there's some of the research aircraft and drones, we can be getting, imagery multiple times per day, although that I wouldn't say that that's the norm. So it's always kind of a moving target. But the bottom line is it gets confusing between what you're hearing on the radio, what you're hearing from air attack, what you're seeing on satellite, and you're trying to interpret all of that, especially in the, on day 2 or day 3 of the fire, when it's starting to move into potentially like, values at risk or whatever. So it's a challenge to decipher, what I put in the comments there, the fog of war, because you will have maybe a crew that swears that the fire crossed this piece of line or whatever, and then the next day when the smoke clears, that wasn't the case. So there's a lot of confusion, and I would say that the gold standard though is more what the aircraft, the IR flights, what they give to us. So pretty much everybody huddles around at 5 in the morning to see what it's showing, because of some of these parallax limitations and whatnot. So it's a confusing time though when you're dealing, with people who swear to God that the fire crossed a river, and you take them at face value, but then it turns out they were confused as to where they were or whatever, or they got confused. They thought one Forest Service road was another Forest Service road. So it's hard to know exactly what's going on.
Yeah, that's great.
Ryan,
That's great insight, Ryan. Sorry, go ahead, Bill.
so if you're on a fire and you're getting all this information, and then you get a perimeter derived from VIIRS, a VIIRS pass in the early afternoon, what would you do with that information then?
Great question.
Yeah, an example of that might be like a place like I'm going to just pick on Happy Camp up in Northern California, where it's a historically smoky area where the aircraft might be grounded. And then at that situation, you can feel like your VIIRS data is perhaps the most accurate piece of information, and so you're sharing that with the decision makers. You're bringing them in and showing them on your computer or whatever. Again, right now, what I'm noticing in California with Cal Fire and other stuff, I mean, there's just a lot of, the technology is changing so fast with drones and other, what I'll call research aircraft or whatever. So it's a moving target. But yeah, if you've got a key piece of information, you try to share it with the important stakeholders.
Very good insight. Please, if you have any questions or more comments, please put them in the chat. And I do want to mention a point on here. Please mute your computers and phones, everyone. On the point of VIIRS and AWIPS, I think currently in the CONUS, we only have near constant contrast imagery available in offices. Sierra has recently begun generating VIIRS imagery for AWIPS, as Curtis put in the chat, so that offices can create the fire temperature RGB and AWIPS, among other RGBs. However, to get this to offices, it takes up more bandwidth. So Chad, can you briefly speak from a regional perspective? So given current SBN and internet bandwidth limitations, is it even possible to get these VIIRS products to offices, or do they need to be made operational? And even if they were operational, would we have the capabilities to get them to forecast offices?
Yeah, so I think the best place for some of these targeted VIIRS, these VIIRS bands, in my opinion, would be the SBN. I know that's like a longer term solution. So what we do when as long as we get a path to operations, right? That's the path. But what we do in the meantime is we bring them over what we call the LDM, which is like an experimental pipe of data, right? And we can pull data from other resources at the regional level. So for example, at Southern Region headquarters, we pull geocolor data, the Sierra product from Sierra. We pull it into Southern Region headquarters, and then we have offices pull that. That pipe is very, very full, so there's very limited space on it. But it's all about how much data you're pulling, right? Like, I think that's a big part of it. And because we would only potentially be pulling a few bands, or maybe the 3.75 and then the fire temperature RGB from an outside source in the meantime, right, as a Band-Aid, it might be doable because it's not a lot of data every 5 minutes or every minute, right? It's a couple times a day you're pulling it in. That's an easier sell on my end. So what we have at Southern Region headquarters is a control change board for the LDM, who goes, like, forecasters make requests. I want this experimental data, I want that. Then we as a group, we vote and we determine if we need to make room on that experimental pipe. So that means something's got to come off usually in order to put something back in, because there's only limited pipe there. Does that kind of answer that for you, Bill?
Yeah. So it seems like you would have to allow for some of those experimental feeds to happen in order to for offices to test it and have a test case and reasoning why maybe this should become operational over the SBN.
That's right. Exactly. And sometimes we do that, right? Like, I'm not sure it would be needed in this case, right? It could, but for a good example is a couple of months ago, I think we did a GOES turbulence product, right? On a satellite book club. That even though we're getting that every 10 minutes, I think, that we're pulling in because there's nothing like it, right? And that's another thing. How unique is the data set, right? Like, so there's things that we weigh, at least at Southern Region headquarters, to kind of have some kind of governance for this. And then we say, okay, we're going to bring it in for 3 months. We're going to gather feedback, and then we're going to reassess. Do we keep it going for another 3 months? Do we need a path to operations, right? Does NWS OBS need to get this product on the SBN potentially? So you can see how that kind of all, is navigated.
Yeah. Thanks, Chad. And on one of those notes, Dan Lindsay mentions that geocolor calculated on the fly in AWIPS using existing SBN ABI data feed is coming soon.
Yeah, that's
and there will
great.
be a satellite book club presentation on that topic probably sometime in May.
So, and that's another, yeah, go ahead, Bill.
Some sites are going to be tested in May, according to Dan, and hoping for everyone in the late summer. Go ahead, Chad.
Yeah, right. And that's a great thing, right? So we've been pulling this data in from SimSierra. It's big. You're getting it every 5 minutes, and it's not even the data we pull in is a little degraded too. I think everything is I think it's 1 kilometer data, but we could really use the high resolution imagery. And the reason why this is so important, because we already have the bands, right? We already have the data. So having that processing in AWIPS on the fly is huge. And then that whole big chunk of pipe that data was using, once these offices get upgraded, that can be removed. It's a great research to operations success for Sierra. And then we can use that space for something else, either another satellite product or something else that might be valuable for the forecaster. It's a really great success story.
Yep. And so how Sierra is sending the VIIRS imagery currently is just by tiles, and forecast offices can request only the VIIRS tiles that are located over their area to limit bandwidth. And Mike Pavlonis mentions that maybe we can further narrow that to the locations of fires to further reduce bandwidth, and maybe only send them when there are fires. That would, of course, take a little more in the algorithm and sending the files, but it could be done, and that would probably be, there are smart ways we can use to reduce bandwidth, I think.
Absolutely, and those are great ideas, and that's what I do. If someone comes to me and I need to be an advocate because I'm a member of our control change board, right? But I'm only one say out of 7, and but if I can provide that information and make sure it's low risk and low cost as in bandwidth, right? It's easier for everybody to buy in, and that's why we got to keep thinking intelligently about these problems, because until we move everything into the cloud, which I think eventually will happen, right? But until we do that, we're going to always struggle with these things, and they're not going away. We've been talking about these problems for years of bandwidth.
Any other comments or questions? Please get them in the chat. We're starting to get near the end of the discussion. John from the satellite analysis branch John mentions that the satellite analysis branch is working on adding new products to its daily satellite-based fire and smoke analysis product with fire perimeter information from VIIRS and other high-res satellites being worked on. And initially it would be web-based. So that's great news that at least fire perimeter information might be coming available. Were you aware of that, Chad?
No, I wasn't. That's great to hear.
Does VIIRS experience any significant parallax, especially since it takes 14 days for the spacecraft to revisit an area of interest at nadir? And Michael, yeah, and we had mentioned, and I dropped a link earlier in the chat, that there was a VIIRS surface displacement, but a correction is applied to the VIIRS imagery now, so that there is no parallax anymore for surface features. And that was implemented last July. Can anyone, or Chad, can you speak to VIIRS perimeter or other perimeter ABI or VIIRS or MODIS perimeter information for fires being assimilated into models? Is that occurring?
So Chris Schmidt might be the best one to chime in on this, but I think I think they use those products, those FDC products, for model initialization of smoke and things like that. That's what I thought that they did, but I'm not a modeler, and I just don't have that info. That's my hypothesis, though. If anyone can verify that, it would be great.
Okay. All right. There was a comment earlier that I think mentioned a simulation, but I can't find it. It might have been Chris. And Curtis mentions that I believe it's only fire radiative power, not perimeters at the moment.
Right. Right. It would be one of those three products, I believe.
And Chris mentioned that as well. Yeah.
Yeah.
All right. Oh, another question real quick. We're about out of time. Does anyone know if GeoXO is planning to include improvements for parallax and resolution?
Yeah.
Dan can drop a comment, but I think the shortwave-IR channel for the imager was going to have improved resolution. Yes.
Right. And right. That's what well, at least that was, I think I heard that's what they would like, right? Not only in spatial resolution, but also dynamic range, I thought too. Is that correct, Dan?
Can someone unmute Dan Lindsay? Or maybe he can do it himself.
Testing, can you hear me?
Yeah.
Yeah, we can. Thanks, Dan.
Okay, cool. Yeah, so right, so there's two improvements we're looking at for the 3.9 band on the future GeoXO imager. One, which has been mentioned multiple times in the chat, is going to 1 kilometer resolution. And another is, as I think Bill just said, increasing the dynamic range, which means it will no longer saturate at 400 Kelvin-ish. It'll be higher than that, and it's TBC, to be determined exactly what. Those are not, neither of these things are guaranteed at this point, but we're sort of in the study phase of the future imager. In terms of parallax, that is a ground processing thing. It's nothing to do with actually building the instrument. So it's something we can look at when designing the ground processing system for GeoXO on really how best to do the parallax correction. It gets tricky, of course, because when you have clouds, they really have a different parallax. And so you would sort of have to do a different parallax between clear sky and cloud, et cetera. But it is a good idea, something we need to look at.
Thanks,
a lot. And we're about out of time, but real quick, Chad, or does someone else know? Right now, only the GOES-16 fire products are on the SBN. Will GOES-17 be added, the fire-derived products?
This is a good question for Jordan, but I believe that the answer is no, they're going to be data delivery. But so you'll still have access to them once data delivery, some of those issues are resolved. Is that right, Jordan?
No, we're looking into it. It's possible that certain products may temporarily or permanently be on the SBN. That's been a late breaking update on that topic. We're very aware that GOES-17 products are not reaching the field offices, and we're trying to remedy that situation. So stay tuned, and we hope to have an answer on that more confidently in the future.
Thanks, Jordan. And okay, I think I'll end it there. Thank you, Chad, for an outstanding session, and thanks everyone for participating. This session will be available as a recording. And with that, I will turn it back over to Jordan for final remarks.
Thanks, Bill, and thanks, Chad, for that presentation. We had a lot of good discussion there. Before we wrap up today, I'd just like to take a moment to celebrate TIROS 1, first light image, April 1st, 1960. It's incredible as we talk about 2 kilometer resolution and 375 meter resolution, how far we've come with our ability to use satellite data. So hopefully everybody appreciates that. And if you're interested in a fun little television show, the Beverly Hillbillies had an episode called Granny versus the Weather Bureau. So go ahead and check that out and see how the how TIROS 1 fared against the Beetle think that episode was from about 1964. Next week, please join us on Thursday, April 8th. Eric Stevens will be joining us, and as has been previously mentioned, he's going to be discussing fire weather in Southern California. Until then, I hope everybody stays well and take care. Thanks, everybody.